Can I start?
Yeah, sure.
Okay. Hello, my name is Praneet Karthigayan, and I've been working on Spatial AI. I've built it from scratch, and I'll show you what it does, and then why I built it, and then a demo at the end. So the core idea was to make space debris monitoring accessible to anyone, not just by big space agencies. I did this by combining computer vision, LLMs, and live orbital data into a dashboard that anyone can use. The reason I felt like this was worth building is that space is getting crowded fast with major tech companies moving uh, computing infrastructure into space, which are now data centers, and which makes knowing what's up there more important than ever. So let me put this into a scale. We can officially track tens of thousands of debris objects, but there are some that are very small but really dangerous, and they're too small for radar to detect, yet still fast enough to destroy a spacecraft. And what is sorry, so what is only a problem for big space agencies is not a problem for big commercial businesses. For example, SpaceX is building orbital data center satellites, and that means that one collision doesn't just destroy one satellite, it destroys the entire network and creates fragments. And in the worst case scenario, it could take down the internet, GPS, and communications infrastructure all at the same time.
Okay.
And here's some real world examples of this. So this isn't hypothetical, it's already happened. In 2009, two satellites collided over Siberia, and one was an active satellite and one was a defunct satellite. And both were instantly destroyed, and those fragments have still been orbiting Earth today. And that event is a perfect example of the Kessler syndrome, where one collision triggers a chain reaction that causes more debris and more collisions, which means that at one point, a whole orbital band could be unusable for years.
Okay.
So Spatial AI, my application, so it has 5 core features. So first we have the debris scanner that you can upload an image and it will scan for debris and tell you where it is in the image. And then we have the chat bot, which you can ask any questions to it and it will answer back and give you information. The third one is the 3D simulator, which lets you watch debris and satellites moving in real time. And you can also play a rescue mission. So then you can see how to avoid the debris.
Okay.
And then we have the satellite tracker. So using Celeste API, we can get the real-time satellite data, and that way you can click on any satellite, see its speed and all of that. And yes, we also have the quiz, which you can just test your knowledge on orbital mechanics and simple AI topics.
All right. Great.
Should we start with the demonstration?
Right.
Okay. Give me 1 sec. My computer is lagging.
No problem.
Sorry. Sorry, I'm having to reset the website.
Okay, no problem.
Okay, not loading. Let me share my screen.
Yeah,
Okay. Can you see my screen?
yeah, it is visible.
Okay. So
Mm,
this is a landing page where the users can just look at what's in the actual application. Here's some like features that the application has, and then just some like extra stuff for them to look at. These are some things that are possibly coming to the application in the future. So here, let me launch it. Okay, so these are the five. This is a full dashboard that the user can interact with. And so first I'll start with the simulator. Let me
sure.
just click refresh feed and it'll load this feed. It takes a little bit of time. It'll load the Celeste Track API. So let's go back and then I can show you the game here. So you hit start quiz and then you can just play the game. I'm just gonna put random answers for this. And here you can look at what you got right, what you got wrong, and then it'll give you a little sentence on based on how much you got right. And you can review your answers as well. And
Mm,
then uh, next I'll go to the debris scanner. Here you can upload an image. Let me upload. I can upload the solar panel image here. Click process capture and you can see the laser scanning. And then it'll give you the metrics of what it think it is, a description is in the main body, and its risk level. And
all
I'll
right,
show you the coordinates. Sorry, the coordinates, the speed, and the diameter based on the image. And then when you click here, you can also see where uh, the debris is in the image itself. So and its confidence level and such.
all right,
Let me head back. And then now this is Nexus. He's the LLM chatbot, and you can just say, ask him a question, and you can ask him to talk about the danger of space debris. I'll click send, and he'll give you a small brief explanation. Unlike some LLMs that'll give you paragraphs and paragraphs, he'll give you a small explanation that's brief and you can understand it easily.
okay, that's great.
And then we have the real-time satellite tracker, which you can load the satellites. Give it one sec. And here you can rotate around the globe and look at any of the satellites, click any of them. And then here you can see the altitude, its velocity, and some more metrics.
Okay, great.
Yes. And then finally to the orbital simulator, as you can see, like the real satellite names have popped up now. So these are all real satellites along with simulated debris because there is no API or anything that can show the real debris. And many
Okay,
of them are untrackable. So um, here you can rotate around the globe and then you can view the satellites. And here is the collision risk. It'll show you the percentage along with what debris is about to hit and the like proximity. And then we have the rescue mission here, which you click start. And your goal is to essentially to increase or decrease the orbit to avoid the debris. So here you have to look at the percentage and like increase or decrease the orbit. Here, if I go below 20%, it's safe. As you can see, it will most likely not crash
right.
depending on the scenario. And Yes, that's my application.
All right. That is quite a great application which you have built, Prince. All right. So I just have some questions which I want to know about from you. So in
Yes,
the third, that is deep learning debris scanner, you have
yes.
said deep learning. So did you actually use the concept of deep learning, or is it the API calling function working there?
So first I tried training a model, and
All
I
right.
used the RoboFlow model. I tried using
Okay.
that, and the accuracy was very low, as it couldn't. It would instantly change its mind during one time to another time, and I didn't have many like high, like very good polished data sets. So I
All right.
was after that I decided to change it back to a Grok API.
Okay.
So it's like a doesn't use it's not completely trained on it, but it's much more accurate than the original model that I had trained.
Okay. Great. And about this image of satellite, so what it is considering that you show it is sharing the coordinates of the satellite, right? So is it
Yes.
sharing the coordinates of the satellite in the image, or is it the actual coordinates that around the space? What are they?
Yeah, it would be in the image
All
because
right.
I would not give it anything else. It would just be the image, plain image, no other background info.
Okay. Okay. Can you show me your code files as well? What
Yes.
code files you have?
Mm, Give me one second.